In these problems, we need to write the equation of an exponential function that passes through 2 points that were given. You'll notice that one of these points is an intercept. It's the y-intercept 0, 4. So we're going to start with that point and plug it into a generic equation of an exponential function. Generic equation is going to look like y equals a, the coefficient out front, times b to the x, where b is the term being raised to the power, a is just a constant coefficient out front, and then y of x, of course, are our variables. Let's start with 0, 4, and let's plug that in for x and y. If we plug in 0 for x, we'll have b to the x, or b to the 0, excuse me, and the other side, y equals 4. We know that anything raised to the 0 power is going to be 1, so even though we don't know b, we know that that became 1, which means that we're just left with 4 equals a. Now, if you notice here, we just ended up with the y-intercept, the y term in this coordinate point. As a shortcut, whenever we're given a y-intercept, you can simply just take the y value of that intercept and plug it in for a, and that will work every time. So you can go ahead and shortcut your way to this equation, y equals 4 times b to the x, when you see something written like this. So now we have problems like we've seen before. Let's take this point, 2, 1, and plug it in and try to solve for that missing b. Well, we have 2 in for x, so we'll have b squared, and on the other side it's equal to 1. If you want to continue solving, you divide both sides by 4 to get that b squared term by itself, and you have 1/4 equals b squared. So now you just need to take the square root of both sides. On the right, we'll end up with just b. On the left, square root of 1/4 is going to be 1/2 or negative 1/2. However, we know that with exponentials, we can't have a negative base because it causes lots of weird problems. So we're only going to keep the positive root here. Even though we're undoing a square, we're only going to keep the positive root because the negative root is not going to work for us. So our b value is going to be positive 1/2. Now if we plug that back into our original equation, we're going to have y is equal to our a term 4 times our b term 1/2 raised to the x power. Let's do one more example. Write the equation of an exponential function that passes through -2, 2/3, and 0, 6. Now if we remember our shortcut, we have a y-intercept here, 0, 6, and so we can take that y value 6 and plug it in for a in our generic equation, which is going to be y equals 6, our coefficient out front, times b to the x. So now we can go ahead and start working with our second point already, -2, 2/3, and plug that in for x and y. If we do that, we have 2/3 equals 6 times b to the -2nd power. Divide both sides by 6 in order to get that b to the -2nd power by itself, and we're going to have 2 over 18. Because we're just going to be dividing this whole term by 6. And we know that 2/18 reduces to 1/9, so we have an easier fraction to work with. And on the other side, we have 1 over b squared, because I wanted to write this with a positive exponent so it was a little bit easier to see. So b to the -2nd is 1 over b to the +2nd. Now, since we have 1/9, or 1 over 9 equals 1 over b squared, I thought it was easier to look at if we inverted both sides, which is something we can legally do. So that's going to leave us with 9 equals b squared. Once you have that, square root both sides, and that 9, square root of 9 is going to be plus or minus 3, but again, we throw out the negative answers, so we're just left with b equals a positive 3. Since we knew that a was 6, because we just stole that with our shortcut, and b is 3, we write our final equation, y equals coefficient out front 6, that's our y-intercept, times 3, our calculated value of b, raised to the x power.